Hey everyone, and welcome to Mr. Ahmed's Math 20 video screencasts. Today we're going to be talking about 2.2, which is the chapter 2.2, which is bar graphs. So getting started, a bar graph, you use that to plot discrete data. And discrete data means data where you've pretty much got it's the opposite of continuous data. And what discrete data means is that the data in discrete data can only have certain values, okay? And they give you an example. They say that an example is the number of students in your class. So the answer has to be a whole number since you can't have half a student in your class. So for example, our class has got 37 students in it, and or maybe 38, right? So you can't have 37.5, right? You can have 37 and a half students. So that's what discrete data is. Okay. Now on a bar graph, you can make a bar graph either vertically or horizontally. We're going to see that the main one that we prefer is the vertical bar graph. Okay. So going right on to example number one, they give you the population of Canadian cities, and they ask you to display the data on a bar graph. So again, just a reminder that you do need a good title for graphs. So population of Canadian cities in 2001, that would be an appropriate title for your bar graph. And again, a reminder that on your x-axis you put the independent value, and then on your y-axis you put the dependent value. Okay, and this is for a vertical bar graph. We're going to see that this kind of changes for a horizontal bar graph. Your independent variable would be the city, so Vancouver, Calgary, Victoria, and your dependent value, that's like the value that you're measuring, that would be the population. Okay, so setting that up on a bar graph, so you got the title, you got the independent variable, which is city, the dependent variable, and there you go. So you kind of just set it up. Make sure that you do put spaces between each bar, because we're going to see actually when you've got no spaces between bars, that's histograms or histographs, and that will actually be the next topic of discussion. Okay, so if you build your skill questions, they're going to ask you to draw a graph or answer questions on the graph. Okay, so example two, kind of the same idea, population, year, population of Moose Jaw, year, and then here's your population. So display the data on both a horizontal and a vertical bar graph. So we're used to displaying it on the vertical bar graph, which is this one right here on the right hand side. You've got the independent value down here, and you've got the dependent value up here on the y-axis. Now for a horizontal bar graph, you literally just take this and you flip it 90 degrees to its right. So you just take it, you flip it on its right, so then you get this bar right here on the bottom, okay, and then this one right here is now here, okay. So again, you just flip it onto its right side, and then now instead of having year down here, by flipping it, you've now got it up here, and your population is now your x-axis. So this is kind of, your horizontal bar graph is pretty much the same thing as a vertical bar graph, just flipped onto its side, okay. Which graph is a better representation of the data? Why? Likely the vertical bar graph, it will be the better representation because you can see the fluctuations better and more easily than you can in a horizontal bar graph. Okay, so the vertical bar graph seems to be a better representation of the data. You can see the population trend more clearly. C is asking, what is the trend in population size in Moose Jaw? Well, looks like it went up from 1980 to 1985, but then since 1985 it's steadily been declining, so it's been going down. Draw a broken line graph of the data. Is the vertical bar graph or the broken line graph a better representation of the data? Here is your broken line graph, and I think we could clearly say that this would actually be a better representation because you can see the fluctuation better. You can see the trend better. Okay, and that's kind of what broken line graphs were all about. Remember, so they were all about kind of showing the trend over time. Okay, so yeah, the broken line graph is better for showing a trend in the data. Okay. Draw a broken line graph of the data so that the graph is misleading, making it appear that the population has declined significantly. So that's E. So here it is, and again, when you're trying to make a graph misleading, you want to have a huge jump from 0 to 31.5 with the little squiggly line, and then what ends up happening is that because of the fact that your graph now starts at 31.5 and goes up to 35, even slight fluctuations here, like of like 0.3, would account for quite a big gap. Okay, so you can, this is misleading in that it looks like in 1980 and then 1985 that there was quite a few people, but then ever since it looks like we've dropped by maybe half that population, if not more. Like this down here looks like it's a third of the population than in 1985. So just a quick look at this graph makes you think, oh hey, in 2000 to 2005, the population was a third of what it used to be in 1985. Okay, so that's kind of how it can be misleading there. And then draw a vertical bar graph using the same scales and blah, and starting points on the axis. Is it similarly misleading? Why or why not? So here is your vertical bar graph. I mean, you could say that it's similarly misleading. It's not really. I mean, it's not really a big deal. Your workbook would have you say that the bar graph does not seem to be quite as misleading as the broken line graph because some of the difference appears to be absorbed in the width of the bars. And I guess that's kind of just depends on people's perception of it. It is my opinion that both seem to be equally as misleading. Okay. All right, so that was example 2. A few build your skills questions. And example 3. So this is a double bar graph. Okay. Yeah, so that's a double bar graph, and the example tells you, so Roger is a real estate agent in Red Deer, Alberta. The graph below compares the average house price of new single-family homes, so new homes, to resale homes. Okay, so you've got 2 bars per year. So you've got your independent variable down here, your dependent variable over here, and you've got the title. And you do have 2 bars per year, and the whole point of a double bar graph is for comparison purposes. So you would want to use this if you had 2 sets of data and you wanted to compare the 2 data. Okay. So for example, in 2002, resale homes, that means homes that are not new, the average would have sold at $172,000, whereas new homes sold on an average for $175,000. So again, this is really just for comparison. So whenever you've got 2 sets of data and you want to compare them, the double bar graph is a good way of doing that. So what was the average price of a new single-family home in 2005? So 2005 is right here. The new home is the one in the gray, so it was $240,000. Between what years was there a drop in the price of resale single-family homes? So between what year did our, so resale homes are the black ones, so between what years was there a drop? That means we're looking for when the bar graphs would have started decreasing. So it looks like it's increasing all the way up to 2007, and then from 2007 to 2008 it dropped, and from 2008 to 2009 it also dropped. Okay, so what is a general trend in the differences in prices, which cost more / less, of the 2 types of units? In which years was this not so? The general trend seems to be that your new homes cost more than your resale homes. Okay, so looking at this, you can kind of see, oh hey, new homes kind of cost more than resale homes. However, this is not the case for 2006 and 2007, where we actually see that the resale homes, so the graph in black here and here, actually ended up selling on average more than your new homes. Okay, so for 2006 and 2007, that trend is not reflective. Does not seem to be the case in 2006 and 2007, whereas in 2002, 2003, 2004, 2005, and then 2008 and 2009, the trend is that new homes on average sell higher than resale homes. Okay, and that was yeah, so that was this example. So you've got more build your skills questions that you can try out. And example 4 would have you work with stacked bar graphs. Now, in all honesty, stacked bar graphs are a little bizarre in that here's kind of what they look like. Okay, so we just did the new home value and the sale home value, or the resale home value in the previous example. And then, so now here's kind of what they did is that they stacked both those, instead of having 2 bars per year, they stacked them one on top of the other. Okay, so it's a little bizarre of a graph, really. So if you are asked to draw a stacked bar graph, Just take instead of having the two bar graphs side by side, make sure that you stack them one on top of the other. That is pretty much it. Okay. And so what's less obvious on the stacked graph than on the double bar graph? I would say almost everything. For example, you can't see which one sold for more. Okay. You can't really see like for example in this year, which one sold for more, the new home or the resale home, and you can't quite tell looking at that. So that's actually a disadvantage for a stacked bar graph. And also, you can't even tell the trend within each set of data. So, for example, if you wanted to see what's been happening to new home prices from 2002 to 2009, well, you'd be kind of hard pressed to say that that this is actually increasing. Like you can look at this and you can be like, oh yeah, well it looks like it's increasing, but that would be something that would be more that you could tell more easily on a double bar graph. Okay. So really, a stacked bar graph doesn't have many advantages. If anything, it's quite a disadvantage making a stacked bar graph as opposed to a double bar graph. So I would suggest that we just kind of avoid this one. Okay, so you don't have to use stacked bar graphs, just avoid those. So build your skills. So you will have to make a double vertical bar graph and a stacked vertical bar graph. Just so that you are able to do the two, and then you would here in D it's asking you what is easier to see on the double bar graph than the stacked bar graph. So just as long as you're able to make a stacked bar graph and are able to talk about the disadvantages of using a stacked bar graph, then you should be okay. Alright, so you've got a few more build your skills questions, and then you've got some practice your new skills questions as well. Okay, and those go up until number 4. Okay, well that's it for chapter 2.2. Stay tuned for chapter 2.3.